Welcome, good morning, good afternoon, wherever you are. I welcome you to our final webinar this year from the RISC2 project. This time we will hear a presentation about HPC system and job monitoring with LLview. And we have two speakers, Vitor Silva and Felipe Guiares. Who are with us. I'm not Esteban Moscos. He's unfortunately couldn't make it on time. He's on a business trip to Uruguay. So I'm jumping in. I'm Bernd Moore from Jülich Supercomputing Centre. So Vitor basically studied in Brazil, and he got his PhD from the Universidade Federal de Minas Gerais. And basically, since last year, he joined the Supercomputing Centre in Jülich. Felipe is a computational physicist. He also studied in Brazil in the Universidade Federal Fluminense. And he also basically moved to Jülich Supercomputing Centre, I think also a year ago or something, or two. Yeah, so let's welcome the both of you, and I'm looking forward to see your screen. Just before we start, let me give you a few instructions. So please interact with us. You can use the chat, the Zoom chat, to ask your questions to the speaker or moderator. Or if you have any issues with a Zoom session, please report it there. We will have basically a question and answer session at the end of the presentation, where we will basically go through your questions. So if possible, keep your microphone muted during the session so we don't have any background noises, and only if you get asked to turn it on, please only do it at that point. As you noted, the session will be recorded, and very soon it will be then available for if you want to rewatch it or pass it on to other people. If you want to don't want to type a question, but you want to ask a question live, you can use the raise hand feature, and but it will be only available at the end in the question answer session, and we then will call you to open your mic and ask your question. So that's it. I hand over to Felipe and Vitor, and yeah, the space is yours.
Thank you very much, Bernd. Let me share my screen here. I hope I get the correct one. Yes, here. Can you see my slides there in full screen mode?
Yes.
Okay. Then thank you very much for the introduction, Bernd. I will start the presentation here, and Vitor will follow in the middle, and then I continue more to the end. And today we're going to talk about HPC system and job monitoring with LLview, which is a monitoring tool that we developed here at Jülich Supercomputing Centre. So first, I want to start with discussing what is monitoring and why do we need it. If you think about any device that you have, you would like to know if it's working as predicted, if there is any problem with it. And for example, I will get an analogy here with a car. In the car, we have the dashboard with many lights and many numbers that show us if there is any problem happening on this system, which is the car. And this could be, for example, high temperature on the car, no fuel, battery problems, low tire pressure, or even the speed itself is an indicator for us to tell this is the speed that we are at this moment. Then this can trigger actions from the driver that we can speed up or speed down, or we need to stop and fix some problem. This is very similar to the supercomputers. In the supercomputers, we have a system that we want to have it in a good usage, and if there is any problem, we want to be able to fix it as quickly as possible. If there is a high temperature, no memory available, so we also want these lights or these indicators in a place for us to access and to be simple for us to identify any problem or bad usage of the system. And then according to these slides, this would then trigger some action from either the user or an administrator or support. And there are different ways of viewing this data, this monitoring data. And we can see, for example, the monitor data for the whole system. For the car, for example, we want to see how it is consuming the fuel, or if there is a problem with the tires and so on. But we can also have information about a given trip only. So if the consumption is very high on a trip, it could be expected because, I don't know, the trip is going uphill, but it could be there is some problem. The driver is using the second gear with 100 kilometers per hour. So there is some problem there, and something should be, an action should be done. But this is also very much related to a performance analysis and tuning, because you get this data which is monitored, but you also have to do something with that. You need to analyze this data, and according to what you have there, you can then trigger some action, maybe call a mechanic, and there is some kind of noise during a trip. You want to know what's going on, so you call a mechanic that will do some extra measurements and will then try to fix the problem, or you even can do it yourself. And as you can imagine, these things are not really independent of each other. There is actually an overlap between them. And this overlap can be bigger or smaller. For example, if you have a car and you know the consumption of the car, you can also have some idea already how it will be in a given trip. Or if you collect all the trips that you have, you already know information about the whole car itself. And this all, of course, can lead you to further performance analysis or some kind of tuning. If I want my car to go in a higher speed, these are all connected to each other. Especially if you are the single driver of the car, you own a car, you are the only one who drives it. You can basically, the system monitoring and trip monitoring have a really big overlap. But if the car actually have many drivers, one of them may not be interested in the trip of the other. So each one of them is more interested in this, in the monitoring the metrics of his own trip. He doesn't need some information of the other trip. Maybe he wants to know some things about the car, the system monitoring itself. But usually he's more interested on his own data. And this is much, in this case, the situation is much more analogous that of a supercomputer, for example, as the ones we have here at the Jülich Supercomputing Centre. We have here Jules and Eureka, and the users then run the jobs on the system, and they want to know information about their jobs. And if they are, if there is any problem or if there is any performance they want to improve, they can then progress and decide to do some instrumentation of the code or some profiling and tracing of the application, and then do some further analysis. And where does LLview enters on this story? LLview is basically, nowadays is very much focused on job monitoring. We monitor all the jobs that runs on our systems. But because of that, we are monitoring all the jobs. We also have a lot of information about the system monitoring. And LLview then provides a holistic view of the system in a central place. We gather a lot of data and put it into a central place. Then we have basically a view of the jobs and of the system monitoring. And then it provides meaningful data to the user and to identify their problem and solve their problems. So this could act, so they have these numbers that are monitored, so they can decide to go one step further and maybe do some performance analysis on the code, and maybe check some problem that he's having, his job is crashing. And this is how LLview enters on this. So the outline of the talk will be this one. We're going to first give more details on what is LLview and how it was developed. Then we're going to talk how does it work and what can it do. And at this point, hopefully you will be curious enough to know how it works in a real scenario, live. We have a demo for this. And we went up with some future plans for LLview. So now I'll give the words for my colleague, Vitor, who will continue a little bit with the story.
Thank you, Felipe. Hello, everybody. So now I'll start talking about LLview monitoring tool. What's this? LLview is developed since 2004 at the JSC, Jülich Supercomputing Centre, and it offers job reporting for all users since its version on 2019. It is in a client-server architecture. It's developed in Perl, Python, and JavaScript. It has an open source license. The asterisk here is just because it's not available now because it's going through a major redesign, but will be available soon. And I just give you the website and contact. Feel free to send us messages, ask any questions about it. So just a little bit of history. Where are we now since the beginning? So Jülich always had large supercomputers with many users from different areas. So there was a demand for a tool to monitor the system and what the users are doing. So this was source of information to help make decisions on the system parameters. So you can see this timeline, and I just call your attention for the small blue box where we have the reference publication for LLview in the case someone wants to cite it. So before LLview, we had an experience of trying to monitor and supervising. I can mention the Trend software developed during 1996 and 1998. It was the first approach on the supervision of batch queues and system utilization, and it was developed in the distributed client-server application architecture. You can see left an example of one window, and on the right, as just for illustration, the website we had at that time, like almost 30 years ago, simple and useful websites. So LLview started in 2004. It's called LLview based on the load leveler, which was the name of the software from IBM at that time. I'm showing you a window from the version 1.02, approximately, because you're not really naming versions at that time. It also follows the client-server architecture applications and had many features. The most important one I want to mention is the mapping job node. So it allowed users to see where their jobs were running and to have a better glimpse of what's going on with their jobs. You can see a window, an example window on the left. Then 2010, we had version 1.3. The main change on the architecture and most important is the LLview DA. It's called data adapter. This makes LLview capable of talking to different machines of different vendors, which allows us to monitor any kind of system we are working or we have at the time. Also, the window at that time, you can see it gets a little bit more complex as the systems get complex. In 2019, LLview was on version 1.8. And the main important new feature is the job in reporting portal. In this case, the users can interact with the reports and using the web, and then check all the statistics and all the metrics important to their jobs, as you can see some examples on the window now. The PDF report is also something that is important for users that want to archive or have some, give some use to the reports or publications or anything that they need to define the details of their running jobs. And finally, from 2020 to 2022, we have the current version of LLview. version 1.9, and it comes with an improved job report and using the JUBREP tool, which is a Python module, used to even make the reports more, let's say, easier to use and interact with a huge set of different graphics and to monitor and check all metrics that LLview is able to collect. Thank you. I'll just give the word back to Felipe.
Oh, thank you, Vitor. Yeah, so that was the current view of the current version of LLview, which is in production now. And so we have, as Vitor mentioned, very complex hardware. The systems are becoming more and more complex nowadays in the hardware side. But on the other side, we also have different types of users from distinct areas, and their programs are completely different from each other. And these things are interact with one another. And we need to monitor this. It's very important to monitor this very, let's say, dynamic scheme. And depending on the role of this user, or if this actor, if he's an administrator or support or users, they will then should have different information of the system. They are interested in different quantities. So this LLview also takes into account to give a role-based access into the information. And how does LLview works? LLview collects information from different sources. So we have, for example, the Slurm information. Well, in our case, we use Slurm, but could be any type of daemon, could be GPU. We can also have network queries, I/O, and so on. And this is also extendable. We can add new adapters to get new metrics that are then forwarded to LLview. And this is then updated every minute using these existing sources. This is an important point because this data is already existing on the system somewhere. LLview then collects all this into a single place. And because of that, it has then negligible overhead. There's nothing new that is making overhead on the jobs and so on. And this also makes LLview pretty much scalable. Nowadays, we have thousands of jobs run per day, and all of them are, we have reports and metrics obtained for that inside LLview. This data is all processed, and then it's forwarded to a system and job reporting portal. And this is then made available for the users, and depending on the role, they would have different access. This is a bit more realistic view of how LLview works. So I won't talk much about this. It's just to show that we have different daemons running on the compute nodes, on the GPU nodes. We can have also the scheduler information, information on interconnect. This is all processed and put then into a database. Actually, I don't know if you can see my mouse. I'll put a laser pointer here. All these daemons are run and processed to a database, and then this database can then creates the information for this LLview client, which shows a live view of the system, or can then generates also this job reporting portal, which I'll then show next. This is how the portal looks like. When you enter the job reporting portal, this is the support view. I'm a supporter. I can see a lot of information, as you can see here, very colorful. On the top, you have different tabs that we have access to. Although the first one, you enter on the website on the active jobs, I want first to talk about the live view of the system. You can notice that this is remaining from it's a, let's say, natural development of what Vitor showed from the history. Here on the top, you have, for example, each of these larger squares is a rack of the system. And inside of these, there are small lines. Each line is a node on that rack. And the jobs that are running, they are color coded. And this is all dynamic. If you hover over one of the colors, you see where they are. I'll show this later on the demo. Then we have, I go back to the active jobs. Here we have a list of all the jobs with basic information, when it started to run, which user, and so on. And some of the columns are color-coded, some of the metrics are color-coded to give some idea that something is bad or something is going well. At the bottom, when you select one job, you get some graphs at the bottom. You also have different tabs there to show CPU information, GPU, interconnect, and so on. And then if you click in one of these links at the right, on the rightmost columns, there are two links. One of them is for the detailed reports, the dynamic reports generating HTML, or a PDF that you can download and store with your jobs. And these detailed reports are nowadays containing a lot of information. We have the basic information plus a lot of these color-coded graphs. Each one of them is information for each node as each timestamp of that run. And talking also about the HTML reports, these are dynamic, where you can hover over, I also don't know, I'll put your laser pointer again. If you hover over a graph, you see, for example, the value of that measurement. In this case, is GPU temperature. And for that given time where the job was running, for that given GPU, the value was 81 degrees in this case. So the value was, let's say, a bit high. Could be a problem, could be not. This is then could lead to other evaluations, other analysis. These are also zoomable. You can just click and drag, select a region to zoom on a particular part that you want to focus. You also have these timelines at the end of the job where you can click and they will then zoom in that given step of the job. And eventually, if there is some error happening, it's also shown at the end of the report, and the node where the error was, there was some kind of error, is also marked in red. So this was just some screenshots. I want to show now a real live view of the system. I hope it works fine. Can you still see my screen now, complete screen with the LLview website?
Yes.
Okay, thank you. So this is the website that it's on the slides. You can see here the just basic information about LLview, and here at the bottom you have links for each of the systems where you want to see the job, where the jobs were running. This is the links point to the current version, which Vitor showed on the slides, but I'll just click here to show you the new version that we hope to make it available in the next couple of weeks. And here it's my login page. You see, I have 3 projects that I participate, that I am a member, and this is then a user view of these projects, because I'm not the leader of this project. I'm not the PI. If I was a leader of a project, I would also have another box here where I would have access to the project view. Instead, I have these other views because I'm a mentor of a few projects, and I'm also, as a supporter of JSC, I also have access to the supporter view. Unfortunately, I also don't have jobs running on this system. I can click here just to show how it goes, but I don't have anything here. Then I will go to another user, because I'm a supporter. I have access to this. I need access to this to be able to help all the users. And for this other user, I can click here and I see the list of the jobs that this user had in the past. It doesn't have any current jobs that are running, but I can see also in the queue, this user would have access to the queue. He can see all the jobs that is running, as in the terminal, for example, with the SQ command. and he can see his own jobs that are in the queue. And when he clicks on a job, he can see the priority, the time to start, the prediction time to start, and so on. And again, as in the slides, he has also a live view of the system, and hovering over one job here, one color, you see that it also shows up which job is this here. And also when I hover over this side, it highlights on the racks. Here at the bottom, we have basically a view of the queue, how it's running, and also it's dynamic. I can hover over that to show, and some prediction here at this top part of jobs that are predicted to run in some hours in the future. At the top, we also have a distribution of jobs by size. So basically, this is the user view. Each user have access to all this. And as you can see, he has only access to his own jobs at this point. And now I want to show this user is a member of this group, 226 is a project. And I want to mention also that this is a demo mode for presentation. So the username, although the usernames are hidden, are not the real ones, these are real information on our system. So now if I go to this group, which is a project view, it doesn't have also any active jobs. But if I go to the job list, I see the jobs from this user, but I also see jobs from other users. So these are all the jobs that are running from this project, which me as a PI, I would be able to see here if I'm the leader of this project. And he has basically the same tabs on top as the user. Now I'll go to this last view, which is the support view, which in my case is the one that I have access because as a member of JSC, of the application support division, I have now access to all the user information, all the projects information. And also if I click on one of these users, I go to this user view and I can see his jobs, and I'll be able to help him to see what kind of information he needs or what problem does he have. Now I just talk a bit more about this view here of the active jobs. I have a list of all the jobs. Here at the bottom, I can choose a color scale. The default one is one that is nicer for colorblind people. I like more this ample, this light signal, like colors. I can choose also to add more information. We collect a lot of information about the jobs. I can, for example, add GPU, return code, and so on to see more information about it. They are all listed here. I can also filter job, for example, for jobs that has more than 10 steps. I can filter this and so on. I can also, of course, click on a column to sort this by that given metric. I also have the live view, and you see new tabs on the top. A system view, I have a lot of information on the system itself, again, because we have all this information on all the jobs, and we can then get information also about the system monitoring. Here we see the nodes that are allocated running jobs. We had a problem on last Monday. The system was not working, but now it's working again. We see how many nodes it's allocated or idle or run and so on. One important thing that I want to make is now that the queue here, I can see all the jobs as in the active jobs. I see all the running jobs. I see all the queue jobs also. And here I have information on all of them, if a job is taking too long to run or not. And I can have information about the reservation. Here in the history, because we have data of all the users, each of dates have a lot of jobs running. We have now a per day view on top. I can select a given day to see the jobs that run that day. And we have also the user projects, information about the users, that how many jobs they are running, and also an internal view, which is internal about LLview itself. It's a meta monitoring, which is very, very useful to develop the codes here. Okay, and one last thing that I want to show here on the demo is that we can click, for example, as I mentioned in the presentation, I can click, for example, in a given job here. I have a download job report as a PDF, or I can show the interactive one. This is basically the report of a job. I have a lot of metrics here, the CPU load, memory usage. This is interactive. I can hover over a point. I can zoom in a part and zoom out. And here I can, for example, by default, we show the limits of the system. In Joules Booster, this is 512 gigabytes of RAM. I can then just change to the job scale to have a nicer view of the job itself, how it's using less or more memory. And at the very end, as I mentioned, we have also a timeline of the system and all the nodes that it ran. This job there's nothing very much different on this. I separated one here that I want to show, which has some nice timeline here at the bottom. You see that this job had 57 steps. So inside one script, it ran 57 different steps. And you can click here on a step to focus on this. But in two clicks, we'll zoom again back. And one thing that I want to show that is very nice is that if I click on this zoom lock here at the bottom, I now lock the zoom on all the graphs. So if I want to focus on this step and click here now, this will now focus all the graphs only on that time range for that given step. So if something wrong happened there, I would be able to see and focus on that quantity. And again, double clicking here to go back, it goes back in every graph. At the bottom here, I can also download the PDF directly from here, or download the data, which are basically the numbers for each of the graphs in case the user wants to process the metrics themselves. And one last report that I separated here. Here on the left side, you can see all the metrics that we have available for this job. You can click on one of them to go directly to it. And here at the last, in this case, I had a job with an error. There was a node error on this. And this the nodes where the error happened are marked, highlighted here in red. Okay, I think this gives some idea of what LLview is and can do. Then let me go just back to the slides just to finish with the talk. I showed general jobs, but now I want to give particular examples where these already helped us to solve problems. One of them was these high temperature GPUs. When GPU is not cooling very well, you see on the left side there was a job with running with 128 GPUs, and one of them was had a high temperature. Because of that, the speed was being throttled down, and the job was running slower than usual. And this we can clearly see from this graph on the left side. The same thing happened on the right side. This was a case where the user noticed that the temperature was higher and the GPU was throttled down. And then he contacted us, and we put then the node into maintenance to fix this problem. Another very common case is that a program can have a memory leak. So every time the memory usage of that code will increase until it reaches the system limit and the job crashes. And this can be clearly seen here when in the memory usage graph. It could be also a bit more on the right side. It's a bit more fancy problem where this memory leak happens only every third node. And finally, one last example is this one where the configuration of the job was incorrect. The user was using 2 nodes, but only 2 GPUs per node, and Julius Booster has 4 GPUs per node. So I contacted the user, and he fixed the issue, and he could then use a single node with all the 4 GPUs, and then because of that, he was not wasting half of the time. Okay, so this is basically what is LLview at the present, as Vitor showed a bit of the history, and this is, of course, is not over. We have lots of plans for LLview in the future. There are many things that we want to do and improve. We want to add new metrics and data sources, always want to add more and more, because it could be useful, of course, but it's not easy to add things in a meaningful way without having being too much confusing. Another important point is that we want to make faster updates in preparation for our Exascale supercomputer Jupyter that will be installed here in Jülich. We also want to make some aggregated reports for a workflow that contains a lot of jobs, or for the whole projects. These are very useful for at the end of a project, if the leader of the project wants to get this information. And of course, another important thing is to show the users about the overall usage of shared resources. For example, I/O is shared by all the users, or interconnect is also shared. The bandwidth is shared by all of them. It would be also important for the users to know if there is a problem on his job, or if it's a system is being overbooked, some kind of resource is overbooked. And finally, this is my last slide, just as an outlook for LLview. We are participating in many European projects, and some of these future plans are also included on these projects. We are also always open to suggestions and requests to add new sources, metrics, and how to present the data. And we love to exchange experience. So we want to know how people analyze and present the report data, or how they use the monitoring in daily HPC support activities. And yeah, we always want to improve how we do things. And yeah, at the bottom, I added again our website and contact. So I thank you very much for your attention.
Okay, thank you very much for this very nice presentation. So we had 2 questions so far. The first question was asked if besides GPFS, also Lustre or ZFS file systems are supported, but someone already answered in the chat that only Lustre so far is there, but of course someone could go on and, if I understand correctly, and write a ZFS adapter to make it available.
Exactly. In principle, whatever is already collecting the data could be forwarded to LLview, and then LLview would then present at the end. So.
Yeah. And then the other question, which was expected, is how do you get access to the source code or to the tool?
That's a very good point.
That's the asterisk.
That's the asterisk that Vitor mentioned. LLview was in the past open source, and we plan to put it again open source, but we are doing a major redevelopment, changing a lot of things in the code. So it doesn't make much sense to put it as available at the moment, because it's changing all the time. And we are nearly, this version that I showed in the demo is the current, let's say, is the version that we are developing. It's almost finished. We plan to make it available before Christmas, in the next 2 or 3 weeks. And after that, we just need to make some kind of cleanup of the repo and make it available again. But if you want, you can contact us. We already have a list of people to contact after to do this.
But just to be clear, it is open source. It's just not available because it's going through this huge re-engineering, and then you have a lot of things that you stay out because they are, let's say, redone, and they are way better now. So we just have to organize the source code to make it available.
Yeah, and like if you are too lazy to check the website every few weeks, just send an email to llview.jsc@fzjülich.de, and they put you on a list, and then you get notified once it's available.
Okay.
Any further questions? You can also raise your hand if you are don't want to type in if you have a longer question. I guess you made everyone happy. Everyone is thanking you for presentation. The recording will be become available on the YouTube channel of a RISC2 project, but you also will get send an email once it's available. Everyone registered on the for this webinar will get an email once it's available and how and where. Okay. So yeah, thank you very much again. So that concludes this webinar, and basically just want to tell you there will be more webinars coming in this series. We are currently putting together speakers for 2023, and if I recall correctly, something like middle of February, we will have a first webinar in the new series. You can look at the RISC2 website early January, or just sign up for the RISC2 newsletter on the RISC2 project website, and then you also will get informed. So thank you again for joining us today, and thank you very much again to the speakers, to the listeners, and yeah, happy holidays, and see you in a future webinar. Thank you.
Thank you very much, everyone, for the attention.
Thank you for your attention.